Find the values of the trigonometric functions of t from the given information. The cosine of t is negative 60 over 61, and the terminal point of t is in quadrant 3. So we have a terminal point in quadrant 3. We can draw a radius that extends from the origin to that terminal point, which gives us an angle, and the cosine of that angle is negative 60 over 61. If we extend a vertical from the terminal point to the x-axis, then we form a right triangle. I'm going to redraw that triangle a bit larger so that we can write on it. Here's our angle. Let's call it theta sub r for the reference angle. The cosine, we know, is negative 60 over 61. That tells us that on this triangle, the adjacent side would be 60, and the hypotenuse would be 61. We have a right angle here where the vertical that we extended to the x-axis joins the x-axis. We can use the Pythagorean theorem, a squared plus b squared equals c squared, to find the remaining side. We would have 60 squared plus b squared equals 61 squared. So we have 3600 plus b squared equals 3721. Subtract 3600 from both sides, and we find b squared equal to 121, which tells us that b would be equal to 11 when we take the square root of both sides. So we'll add that to our triangle. Now, in order to find the values of the other trig functions, we can use this triangle and keep in mind that in the third quadrant, x and y are both negative. The sine of t, then, would be the opposite over the hypotenuse, which would give us negative 11 over 61. The tangent of t would be the opposite over the adjacent, which would give us negative 11 over negative 60. The negatives would cancel, and we would wind up with 11 over 60. The cotangent of t is just the inverse of the tangent of t, which would give us 60 over 11. The secant of t would be the multiplicative inverse of the cosine, and therefore would be negative 61 over 60. The cosecant of t would be the multiplicative inverse of the sine of t, so therefore it would be negative 61 over 11.